Alright, so in this video I'll be going over the test 2 review on chapter 3. Well, let's get started. So this first one we can write as the square root of 10 times the square root of negative 1. And we want to remember that the square root of negative 1 is I. And so this is just the square root of 10 times I. So here, this is the square root of 64 times the square root of negative 1, or 8i. On letter C, one of the things I said is if you have a negative under the radical, one of the things you can just do as a shortcut to what we just did is just pull an I out and make the radicand positive. Because if you take the square root of a negative number, you will have an imaginary number. And in this case, that's all we can do. That is our answer. It's negative square root of 14 times I. On letter D, we know that if we have a perfect square factor, if the radicand has a perfect square factor, let's see, 16, 25, other than 1, that we can simplify this. It's not considered simplified. So in this case, we could write this as the square root of 9 times square root of 5, which is 3 square roots of 5. Number 2. So when we simplify these expressions, it's a lot like when we normally do regular algebra. So if these were x's, we would drop the parentheses and combine like terms. So we have a minus 2 and a plus 7, that's 5. We have a plus 4i and a minus 10i, that's minus 6i. And so that's our answer. When we add two complex numbers, we get a complex number. These are actually imaginary numbers, and our answer is an imaginary number. So it's very similar here, except for when we drop the parentheses, we're going to have to distribute the negative here. We'll get minus 4 and plus 9i. So we can combine 12 and a minus 4 to get 8. A minus 3i and a plus 9i is 6i. And so 8 plus 6i is what we get there. On this one, we're going to use, we're going to FOIL. So 4 times 3 is 12. 4 times a minus 2i is a minus 8i. Here we're going to have a minus 15i. And the last product is plus 10i squared. But remember, I squared is negative 1. So we have 12, a minus 8, and a minus 15i. Minus 8i and minus 15i is minus 23i. And then this is going to be minus 10. So finally, we'll end up with 2 minus 23i. All of these answers, you'll notice, are in the form a plus bi. We call this the real part and this the imaginary part. So here we're going to need to FOIL. We'll multiply 2 of these 2 plus 7i's. So as we do these problems down below, just remember we have two things we needed to remember: that square root of negative 1 is I, and our I squared is equal to negative 1. And so when we have the I squared here, we're not simplified. We have to multiply 10 by negative 1. And so just be careful that you change your I squareds. So here we'll do 2 times 2, which is 4. Our outer product is 14i. Our inner product is 14i. And our last product will be 49i squared. Remember, I squared, that's negative 1. So this is going to be a negative 49 and 4, which is negative 45i. And then we have these two 14i's, which add up to 28i. On letter E here, we learned that this is not simplified. We still need this a plus bi form. And the way to get that is we multiply by the conjugate of the denominator, which would be 5 minus 3i. So we'll have to do the same thing to the numerator. So we got a lot of foiling to do. So we're going to have 10 minus 6i minus 5i plus 3i squared. That's in the numerator. In the denominator, we're going to have, these are conjugates, so we'll just, remember the inner and outer products are going to add up to 0. All we got to do is multiply the 5's. We get 25. And 3i times minus 3i is minus 9i squared. But remember, our I squareds are negative 1s. So we're going to end up with 10 and negative 3, so that's 7, minus 11i, negative 6i and negative 5i. And in the denominator, this is going to end up being a minus 9 times a minus 1. That's going to be plus 9. So 9 and 25 is 34. So finally, to put it in the right form, we would write the 7 over 34 minus 11 over 34 times I. So there's your A, your B, and your I. All right. And so that's basically simplifying radicals and then simplifying expressions with imaginary numbers. Let's go ahead and look at number 3. So we've got to solve some quadratic equations. And here we get to choose. So I'm looking at this here, and I'm seeing that these terms have common factors. So I'm thinking I want to put them on the same side and factor out a GCF. In this case, it would be 3x. So it'll be 3x times 2x minus 1, and that's equal to 0. So then once we factor, we set each of our factors equal to 0. So here we're going to get 0. And here we will add 1 to both sides. We get 2x is 1. Divide by 2, you get x is 1/2. So we know with quadratic equations, we're normally going to get 2 solutions. Now when I look at this one, I could probably do it using factoring, but because I don't see an x term, this is a great problem for using the square root method. So let's divide by 2. And when we do the square root method, remember we want to get x squared by itself and on the other side a number, and then we'll take the square root of both sides. So we get x squared is equal to negative 16. So I'll rewrite that so you can see my steps. I'm going to take the square root of both sides. You got to remember to do that plus or minus thing. You get x equals plus or minus. Now remember, this is the square root of a negative number. So we're going to get an imaginary answer here. Remember, this is square root of 16 times square root of negative 1, or 4i. And so this will be plus or minus 4i. If you want, you could write 4i and negative 4i, but this is fine the way I wrote it here. So as I look at letter C here, I'm thinking this is, first of all, it's a trinomial. It's in standard form. We got the x squared term, then the x term, then the constant. 0 on the right side. I'm thinking, hey, I'm going to try to factor this. If it doesn't factor, then I'm going to use quadratic formula. So we need 2 numbers that multiply to AC, which is negative 18. And our B term is negative 7. So these two numbers multiply to negative 18 and add to negative 7. Now you may want to stop the video and see if you can do this one if you haven't already tried it. The numbers at work here are 2 and 9. One of those has to be negative, and since they add up to a negative 7, it's got to be the 9. So notice 2 times negative 9 is negative 18, and 2 plus negative 9 is negative 7. And so because this is not a 1, x squared, we're going to have to split our b term. There's no shortcuts on this one. So we're going to put in a 2x and a minus 9x in the place of negative 7x. Notice these do add up to negative 7x. And I'm just going to focus on the factoring right now. So now we can factor by grouping since we now have 4 terms. This will be 2x times 3x plus 1. So when I factor here, I'm expecting a 3x plus 1. And notice to get that minus 9x, I need to multiply by negative 3. And then notice negative 3 times 1 also gives you this other negative 3. So we're going to end up with 2 terms with a common factor of 3x plus 1. And if you cross those out, you can see the other factor is 2x minus 3. Now don't forget, we were solving an equation. This is set equal to 0. So we want to set 3x plus 1 equal to 0 and 2x minus 3. So we'll need to subtract 1 here. We're going to get 3x equals negative 1, which means x is negative 1/3. And on the other one, we'll add 3 to both sides. We get 2x is 3. Divide by 2, you get x equals 3 over 2. All right. On number 4, we're going to solve by completing the square. So what we learned is we want the x squared term and the x term by themselves on one side. So we're going to go ahead and subtract 5 on both sides. And so we'll get x squared minus 12x is equal to negative 5. So now we're going to complete the square. And this is the way I normally set it up. So we need to take half of negative 12, so negative 12 over 2, and we're going to square that, and that's what we're going to add there to complete the square. So this will be negative 6 squared, which is 36. So we're going to add 36 to each side. So now remember, we can write this as a perfect square. Let's go ahead and move this down. This is x minus 6 squared equals 31. So I'm going to move this over here so I have enough room. Also, I'm going to take the square root of both sides. I just wanted to point out this minus 6 here is just half of the negative 12. If you actually multiply 2 of these x minus 6, this would be what you'd get, x squared minus 12x plus 36. So now that we've got it as something squared equals a number, we'll take the square root of both sides. Don't forget your plus or minus on the right. So we're going to end up with x minus 6 is equal to plus or minus the square root of 31. We need to solve for x, so we'll add 6 to both sides. Now, you can't add a radical with a number that's not a radical, so we'll just put the 6 first, and then the plus or minus, and then the square root of 31. And so that's your answer there. And I think we'll just finish up this page. On number 5, it says find the zeros of each function. So to find the zeros, we want to set the function equal to 0. So we have 3x squared minus 18 is equal to 0. Now I'm thinking, well, first of all, this is a quadratic equation, but the other thing is there's no x term here. Whoops, hold on a sec. So we're going to use the square root method. So let's add 18 to both sides. Get 3x squared equals 18. Now be careful, I can't take the square root of 3x squared because the 3 is not a perfect square. I want that x squared by itself, and so I'm going to divide by 3 on both sides. And so we're going to get x squared equals 6, and we'll take the square root of both sides. And we get x equals plus or minus square root of 6. Oops, and I ran out of page there. Let's move on to 5b. So here, so keep in mind, we just found the zeros here, so if you actually plug in the square root of 6 or negative the square root of 6 into this function, that's what would cause this function to equal 0. On the next one here, we have g of x equals minus x squared plus 3x plus 54. So let's set that equal to 0. Well, I don't like having that minus x squared out front, but it's pretty easy to fix. Notice if I multiply each side by -1, on the left, each of my terms will change sign. So I'm just multiplying by -1 on both sides. When I do that, I got to multiply the whole thing, each term. And so we get x squared minus 3x minus 54 is equal, notice, -1 times 0, 0. So in this case, this is the easier type to factor using the AC method. We need two numbers that multiply to -54 and add to -3. 6 and 9 are going to work. And the 9 will need to be negative. Notice when you multiply, you get -54. And when you add, you get -3. Now in this case, because it's a 1x squared, which is different than what we saw on 3c, we can just go ahead and put x and x, and our two numbers are +6 and a -9. Again, you can see that these two numbers multiply to -54 and add to -3. And then finally, when you set each of these equal to 0, you're going to get -6 and 9. So those are our two zeros for this function. Alright, I'm going to go ahead and stop the video here, and I'll make another video. There probably will be several of these.